Okay, 19 kilogram rocket, of which 12 kilograms of which is fuel, burns fuel at a rate of 0.465 kilograms per second. What are its initial and final accelerations? So step one, let's figure out the initial mass, and that's given to us. I guess in these problems, I just always give it to you. Right, and then the final mass is going to be the 19 minus 12. Is that 7? So there's our initial and final masses, right? Okay. That's important. We got to figure that out. So when it's just about to run out of fuel, it's only got a mass of 7 kilograms. And then the thrust, we are going to go force times time is mass delta V. Okay, so what I'm going to do here is I'm going to use this thing here. This is both a mass and a time. We know that in 1 second, because this mass has to go with this time. This time must be the time it takes to burn that mass of fuel. So I'm going to use this thing. I'm going to use the 0.465. I could figure out the time it takes to burn all the fuel and use 12 as the mass and that time, but that's working too hard, I feel. So let's go with our time is 1 second and the mass is 0.465. Okay? So I'm going to go force times 1 second is equal to 0.465 times 748. All right, there we go. Okay, so just this times this, right? 0.465 times 748. It's 347.82. There we go. So 347.82, that's going to be our, that's going to be the force, the upward force. Okay, let me just double check this. Yes, okay, we're good. Now let's figure out the initial weight, right? The initial weight, the force of gravity initially is going to be 19 times 9.81. And that's 186.39. Okay, and then the final force of gravity is just going to be the 7 kilograms, right? 7 kilograms times 9.81.
Oh, okay.
7 times 9.81 is 68.67. All right, here we go. Now we are ready. Now we are finally ready to figure out those initial and final accelerations, okay? So initially, we've got this thrust here, 347.82. And this force of gravity acting against it, right? So that's going to be down. Right? And then that equals 19 times the acceleration. We can do this. I can do this. Collectively, we can do this. So this guy minus this guy. I'm using the up arrow on my calculator. Divided by 19. And that's 8.496, so 8.50 meters per second squared. That's our initial acceleration. Now at the end, there's still the same thrust, so 347.82, but the force of gravity is much less because there's less mass, right? So minus 68.67. And then there's less inertia too, right? So 7.0 is our inertial term there, or inertial factor. And then A is what we don't know. So 347, that guy, minus the 68.67 divided by 7 is 39.87, so 39.9 meters per second squared. So humans could actually survive an acceleration like that. They just couldn't fit into a rocket that small. But anyway, all right. Hope that helps.